Resistors in parallel. When resistors are connected in parallel, they have the same potential difference across them, and components in parallel have a common voltage. Look at the diagram. The voltage between the ends of each lamp is the same. Using symbols, the diagram becomes thus. A parallel circuit is one that has more than one resistor, and the resistors are not connected end to end. Therefore, there is more than one path for the current electrons to follow. Look at the diagram. From one end of the battery, the electrons move along more than one path with branches through the resistors to the other end of the battery. The current through them will be different if they have different resistance. Pay attention and follow the path of the current in the diagram. Any components in parallel have the same potential difference across them. The total current can be calculated by Ohm's law. Change the subject. To find out the current through the resistor 1, we also must use the Ohm's law. And we must do the same to find the current through the resistor 2. When resistors are connected in parallel, the supply current is equal to the sum of the currents through each resistor. Now let's substitute the currents by the expressions on the left. The voltage is common factor in this expression, dividing both sides by differential potential. We get the formula to calculate the total resistance in a parallel circuit. Now it's very important you notice the difference between the series circuits and parallel circuits. In series circuits, current is the same through each resistor. In parallel circuits, current is split between the resistors. In series circuits, the total potential difference of the power supply is shared between the resistors. In parallel circuits, the potential difference is the same through each resistor. In series circuits, the total resistance of the circuit is. In parallel circuits, the total resistance of the circuit is. Now let's calculate the equivalent resistance in each circuit. It's easy to calculate the equivalent resistance in a series circuit. To calculate the equivalent resistance in a parallel circuit, we have to work a little more. Put the fractions in the same denominators. You should see that adding resistors in series increases the total resistance in a circuit, and adding resistors in parallel decreases the total resistance in a circuit. Series circuits have a serious problem compared to parallel circuits. In addition to increase the resistance, the series circuit consists of just one loop of wire, so a series circuit has just one current. Therefore, if one resistor in a series circuit fails, then all the components in the circuit fail because the circuit has been broken. This problem does not occur with parallel circuits because current does not have a single path to follow. Example. A potential difference of 24 volts from a battery is applied to the network of resistors in figure below. Calculate the equivalent resistance of the circuit. Calculate the current in each resistor. Calculate the total current. Put the fractions in the same denominators. To calculate the current in each resistor, we use the Ohm's law. The voltage is the same in each resistor. The total current is the sum of the currents through each resistor.